receive the interesting knowledge from Arai Sensei. I think we sincere hope this webinar will not only broaden your knowledge but also inspire the future research and international collaboration. I think. Um, I don't know how to open in English. By Indonesia, we always say by saying Bismillahirrahmanirrahim, we officially open this event. Thank you very much.
Okay, thank you, Bapak Dekan, Bapak Dr. Afdhal. He's also doing or getting his PhD from Japan, ISSX. Okay, we also honored by the presence of our Vice Dean of Academic Affairs, Bapak Helmizar, our Head of Department, Ibu Studi Herawati, and also Bapak Adadi and Bapak Arfan. Okay, I think if we are ready, we can start with your lecture.
Sure.
Sure, nice.
I'd like to share my presentation material. I'm requesting to allow me to share the slide.
Okay, please wait. Pak Arfan, please.
Sudah Pak, sudah Arfan. Halo.
Okay, it is open already.
Now I got. Can you see this?
Yes, now we can see it clearly.
Okay. AI-powered information retrieval. That is the title of the international webinar. A special lecture for the Universitas, your university. Bengkulu University. Unfortunately, I don't have enough time to explain the AI-powered predictive analytics for the in particular business. If I have another opportunity, I will talk about the AI-powered predictive analytics and the big data analysis for business. This time, I'm concentrated on the AI-powered information retrieval. You must know the information retrieval. Search engine retrieve the information through the internet. This is the definition of the information retrieval. It is science of searching for information in documents, searching for documents themselves, and also searching for metadata, data of data that describe documents. Usually we use the keyword, several keywords to retrieve the specific document or data in the database. With the rise of the massive digital data, traditional IR systems have evolved with the integration of the artificial intelligence, especially deep learning and neural network models, architectures, to deliver more relevant, context-aware, and efficient search results. Nowadays, MCP lag. You know, what does MCP lag stand for? MCP stands for Model Context Protocol. RAG stands for Retrieval, Augmented Generation. Such this information retrieval techniques are getting much popular. Here I have the AI information search systems. In the center, AI search engine is situated. The user asks with the natural language and access to the data source, data in the database through the AI search engine. In this case, natural language processing is needed for so that the local large language model, LLM, is highly required for this AI search engine. The key features of the AI search is that a high precision of the search through semantic understanding and context-aware result ranking will be provided by AI search engine, integrated information retrieval from the multiple sources. This one here, user can ask the AI IR systems with the natural language. This is a host, AI host. AI search engine is an AI client, AI agent, client agent. And here I have the data sources. These are data server, database, and web. Some other information sources are included in. This is the standard system architecture of the AI information search systems. Going back to the 1960s, Boolean search is dominant. After that, TF-IDF, vector space, is used for the information retrieval. 1990s, BM25, page ranking is dominant. After that, year 2006, deep learning was published by the Professor Hinton of Toronto University, Canada. After that, 2010s, deep learning makes a great impact to the artificial intelligence. And nowadays, transformers, large language models are there, so many. And firstly, I will explain the traditional information retrieval, followed by modern AI and machine learning approaches and neural networks. Well, rely on the exact keyword matching and the statistics. That's why keyword, many frequently appeared keyword is a specific feature of the information retrieval. And then we can understand the semantic means and the context by using the AI technology and machine learning. And neural networks revolutionizing how we represent and match the text so that the year 2020's Transformer has divided into three categories. One is the encoder, second one is the decoder, third one is the encoder and decoder with LLM, large language model. There, small sized and big sized. Nowadays, ChatGPT, OpenAI provide the GPT 5.3, that latest version uses the large language models, and they provide the 120 billion, the parameters of the GPT 5.3, and the 20 billion. That is the minimum size of the OpenAI provide. And the most smallest large language model is provided by DeepSeek. They provide 0.5 billion of the parameters of large language model. So 0.5 billion can be installed in your computer. We don't need that big functionality, big memory devices, just 20 terabytes of the memory will be enough for install the 0.5 billion of the parameters of the local language model provided by DeepSeek, so that the one PC can be used for one LLMs. Nowadays, firstly, classical information retrieval, I will explain. First one is a bag of word, BOW, BOW. BOW model represents documents and queries as a vector of the term frequencies. So a frequency is a key issue for BOW. Early information retrieval model, vector space, Boolean algorithms, and probabilistics models rely on these sparse representations, followed by BM25. It's a ranking function. So it's most likely, second likely, third likely, some other, something like that. So with the BM25, we can rank the most reliable retrieval result, and followed by second candidate and third candidate, la la la. And invalid index, efficient data structure for fast document retrieval based on term occurrences. So frequency is a key issue here. This is the example. The cat sat on the mat. In this sentence that appeared second time, 2 times. Cat 1, sat 1, on 1, mat 1. So most word frequency is mostly that is that most frequent word. It's 2 times. That's why that is first ranking, and the second ranking cat sat on mat. These are same rank. In this case, ignores grammar, word order, and sentence structure. Just focus only on word frequency and presence. That's why sometimes information retrieval accuracy is pretty bad. So another information retrieval using the artificial intelligence is highly required. Example of the bow, word order is lost. Only frequency matters for the matching and the ranking. Here's the example. Machine learning is powerful. Machine learning transforms data. This is a sentence. 2 sentences. Bold representation is like this. Machine, second, 2 times. Learning 2 times is 1. Powerful 1. Transforms 1. Data 1. Such as frequency, only a frequency matters for matching and ranking. So that the first rank of the word is a matching and learning. And second ranking word is yes, powerful, transforms data. Now this is the model of the bag of word. Term frequency, TF, can be expressed with this equation, count of the term T in document D. In the document, D document, term T is included in, and the count of the term is represented by T, so that the TF is a function of the T and D. This is the original TF function. Normalized TF, total terms in D divided by, so that the count TD over the total term in D. This is the normalized TF. High frequency indicates higher importance in the document, but common words like the, is also have high frequency. It's quite obvious. That's why, in this case, the TF-based information retrieval omit the such this high frequency word. Otherwise, we will make an error in the information retrieval. Inverse document frequency, IDF, can be expressed by this equation, logarithmic function of n over dft. So how rate over the importance. That is the definition of the IDF. In this case, n denote total document, and DFT denote document containing term T. so that some sort of inverse TF, that is IDF. Real term get higher IDF score. Common term appear in many documents get lower score. And same things, that is and are, such a words are omitted for the IDF-based information retrieval. Thirdly, the TF-IDF ranking function is proposed. Combined TF and IDF, TF-IDF can be expressed. Document score for query. In this case, we need to calculate the score. Score is expressed with as a function of the Q and D. TF-IDF, summation of the TF-IDF for all term T in query Q. And query Q and data TF-IDF, if the TF-IDF in the database and the query Q are matched, then the score getting higher. Balances local importance TF with global reality IDF. This one here is the TF-IDF stand for. That's why we can calculate the score. And the most widely used ranking function is still using this score in the information retrieval. After that, BM25 ranking function is invented. Best match 25. BM25 stand for state of the Earth probabilistics ranking function. BM25 is expressed with IDF multiplied by TF over TF total. So key parameters here is that K1 control term frequency saturation typically is set up at the 1.2 to 2.0. And B control the document length normalization, typically 0.75. And prevents over rewarding long document or repeated term, so that the PM25 is an indicator for the matching between the query and the data in the database. That's all the fashion now the information retrieval. From now on, you will have the AI and machine learning in information retrieval, learning to rank LTR, so that the query document, their interactions between both page rank term, frequencies, user clicks, such these events are input data for the machine learning and AI learning model. Machine learning model, logistic regression, boosted trees, and neural networks. Boosted trees means the For instance, gradient boosting is included in the boosted trees, and the logistic regressions. These are learning model. So by using the page rank, term frequency, user click, such this data, the learning model is trained. The word embedding is another technology. Static embedding techniques like word to back. This one here is the if I have the word can be converted to the vector. That is can be done with the word to back. Same thing with obey and the first text map, each word to dense vector, capturing semantic similarity. You must know the vector, the relationship between the two vectors can be expressed with the cosine theta. That's why once we convert the word to vector, then we can calculate the similarity between two vectors, two words. Contextual embedding models like BERT, RoBERT, and GPT generate context-dependent representations for each word. Here I have the comparison between the traditional and neural IR, information retrieval. Traditional IR, keyword matching is dominant, statistical feature, exact term overlap required. Yeah, no semantic understanding at all. Fast but limited, the poor accuracy. On the other hand, neural information retrieval, semantic matching can be done, learn the representations, understand synonyms and the context, captured meaning, more accurate but slower. Once we create the learned model, then it's accelerated.
Tadi
Modern systems combine both approaches for optimal performance. Word embedding, as I mentioned before, word to back is a typical. Globe and fast text. This is the example. Word king can be converted into this vector. This is just an example. Similar words have a similar vector representations. This word embeddings has the advantage of capturing the semantic relationship so that this is an example, king minus man plus women nearly equal to queen. This is the semantic relationship between king and queen. Limitation. There is a limitation. One vector per word, of course. No context sensitivity, of course. So this is the limitations. Neural ranking models. Deep learning is used for the rank of the similarity, contextual similarity for the relevance scoring. Query document, this is the input text, neural network, feature learning, and rank relevance score will be output. DSSM, Deep Semantic Similarity Model, KNRM, stand for Kernel-Based Neural Ranking, Deep Neural Network for Ranking, Match Pyramid, Hierarchical Matching Network. These four learning model is a famous for the ranking models. Here I have the another models, so-called BERT and the Transformers, revolutionary architecture from the since 2018 self-attention mechanism. Self-attention mechanism is a key issue. Self-attention loss function can be decreased by through the training, enables contextual understanding of language. So BERT understand the language. Transformer encoder means word to vector and the vector to word. Such transformation can be done with the transformers. Contextual embedding, word meaning depends on the surrounding word, so that not only the single specific word, it's analyze the surrounding word together, so that the contextual meaning can be understandable. Pre-training means learn the model. Fine-tuning, pre-tuned model is there and there. And we used to use the pre-trained model by using the fine-tuning of the specific user-specified word. That is called fine-tuning. Additional training, learn from the massive data, adapt to information retrieval task, and bi-directional context, so that the forward context and backward context, such interpretation can be done with the BERT and transformers. These are famous learning model: BERT, Robota, T5, GPT. You must know the GPT. OpenAI provide the GPT. Dense retrieval systems, on the other hand, encode query and document into dense vector embeddings. As I mentioned before, the relation between two vectors can be expressed with the cosine function. Retrieve by similarity, cosine theta, in embedding space. Here I have the query encode to the vector, and if I have the vector, can be decoded to the word query. And document is also vectorized by using the encoder, and the similarity matching can be done between two encoders, two vectors. That's why the most appropriate document can be provided to the users user's query. Hybrid search architecture is there. User query, BM25 search, and the dense search as well. And this one here is a keyword matching. Dense search provides the semantic matching, and we can use these ranking score combined together, and fusion, re-ranking can be done. This is called hybrid search architecture, combined traditional and neural semantic search. Best of both worlds, precision of the keyword, and as well as the semantic understanding can be done. Learning to rank, LTR, machine learning model learned optimal ranking from the training data. There are three main approaches: point-wise, pair-wise, list-wise. Point-wise, it predicts relevance score for each document. And the pair-wise, you must know the minimal pair we can select, then we can calculate the matching accuracy and the score. Compare document pairs, learn which is more relevant. On the other hand, list-wise optimize entire ranking list. List-wise directly optimize ranking metrics like map and most appropriate the probability most sophisticated approach is LTR, learning to rank. Real-world applications, web search. So many web search engines are there. Bing is one of those, and Google and the Yahoo search, some others. Being used the BERT for query understanding. E-commerce, Amazon, eBay use the neural ranking systems for the product search. Enterprise search, search, Sora, integrated dense retrieval, as I mentioned before, context retrieval, question and answering systems, ChatGPT, Claude, some other generative AI use the retrieval augmented generation. Retrieval augmented generations. RAG stand for recommendation system, YouTube, Netflix, Mercari, some others. Leverage neural embedding they are using. Multimodal search, text, image, video, voice, some others, and personalized retrieval. Personalized retrieval means that if the specific user conduct the information retrieval with the keyword, then artificial intelligence can understand the user's personality, preferences, some others, so that the artificial intelligence provides some recommendations, such and such. This is the real-world applications. Challenges in neural information retrieval. First one is the computational cost. Neural models are resource intensive. and latency, delay time is occurred so that the fast inference is a challenge, one of the challenge. Training data need large amounts of the relevance data. So OpenAI uses their own large amount of the relevance data. But DeepSeek uses, they open their LLMs to the world. Then many users put their labeled relevance data. So training approaches are the difference between the OpenAI and the DeepSeek. Interoperability, black box model, hard to debug, and we cannot explain the logic why such a retrieved result comes out. So interoperability, interpretability are not ensure the neural information retrieval. Index box dense pixels require more storage. So storage mass is quite huge. Now one of the solutions are here, model compression and caching and approximate search and hybrid systems. These four is a direction to the future. Key takeaway from the previous explanation. One is the evolution from keyword matching to semantic understanding. Nowadays, semantic understanding. What are the embeddings foundation for neural information retrieval systems? Transformers revolutionary architecture for context understanding. Dense retrieval, semantic search in embedding space. Hybrid approach combine the traditional and neural approach. Learning to rank, LTR, machine learning optimizes ranking from data. In the future, multimodal, personalized search, and conversational search. Future directions. Now, from now on, I will explain the neural information retrieval. First one is a convolutional neural network, captured local patterns and proximity relationship. So not only the one specific word, but also the surrounding world can be interpreted by convolutional neural network. Second one is a transformers, complex interaction between all pairs of tokens, inquiry, and document. Yes, information retrieval allows us to calculate the score between two vectors from the two different words and sentences in query and in document. Cross-encoder input both query and document together into a transformer, namely BERT is doing the input both query and document together into a transform. Modeling and relevance scoring can be done with BERT. Representation focused models, dual encoder independently encode queries and document into dense vector. enabling efficient vector search and scalability. Vector search is uses the nearest neighbor search in high dimensional embedding space. Here I have the comparison among the neural language processing, machine learning, deep learning, semantic search, and RAG, retrieval augmented generation. Here I have the descriptions, natural language processing, BERT can be done, can be done with the BERT T5 and GPT, Chat GPT, LangNet and Lambda Mart, CNNs, deep learning, transformers, dense passage retrieval, semantic search, RAG, OpenAI GPT per search engine. Integrate retrieval with the generative model to improve answer relevance and accuracy. Nowadays, the trend of the research work is focused on the transformers and LCP lab. First one, natural language processing, BERT, T5, and GPT are large language model based on the transformer architecture. So a transformer is a key is here. The BERT is favored for understanding context GPT for generating fluent text, and the T5 offer the most flexibility by handling any text in, text out task. BERT stands for bidirectional encoder representations from transformers. BERT. Transformer encoder only. Yes, BERT has a transformer encoder. BERT is pre-trained model. So if you installed the BERT into your PC, then you can use BERT as a LLM, large language model. So you can ask the task to the BERT with the natural language, Indonesian language. Text to text transformer TTTTT. T5 stands for treat every natural language processing problems, classification, question and answer, generation, translations, as a text-to-text task. Uses a full encoder-decoder. So a T5 has not only encoder, but also decoder. Otherwise, we cannot translate the word sentences. Translation can be done by using encoder, and if we use the T5 of the decoder, then transformed translated data, word, sentences, or output, maximizing its versatility, but required more computational resources than BERT or GPT. So that the transformer, encoder, and decoder is very, very sophisticated, most accurate models, but It's used for the translation, not the information retrieval, because it's required the huge computational resources. GPT stands for Generative Pre-trained Transformers, GPT, excel at open-end text generation, summarization, and dialogues. Uses transformer decoder only. GPT doesn't need any encoder. Transformer decoder only. Unidirectional, not the bidirectional. BERT, both bidirectional. And the T5 bidirectional. But GPT is a unidirectional, causal attention. So in the learning model, there is the loss function, and loss function can be expressed with the causal attention mechanisms. The comparison among the three models, BERT, GPT, and T5, is shown here in table. BERT best at understanding, GPT best at generation, T5 best at both, because the T5 has encoder and decoder. GPT decoder only, BERT encoder only. The future trend of the AI-powered information retrieval. First one is a shift from the traditional search, traditional information retrieval. There are so many limitations, struggles with the ambiguity. For instance, Java could mean the coffee or programming language. Such this ambiguity it has. And AI revolution, modern AI, particularly large language model, LLMs, transformer-based architecture, is moving beyond the keyword. This enables a more intuitive, human-like search experience. So most of you using the ChatGPT or Gemini or some other generative AI, it uses the transformer-based architecture. Here I have the trend one, future trend, retrieval augmented generation lag. What the lag is a hybrid AI framework that combines traditional retrieval with generative AI models. How it works. Retrieval can be done with the learning model, generation, large language model, then synthesize this retrieval information into a coherent, context-aware answer. Key benefit is reduce the hallucinations. Generative AI tells a lie, but retrieval augmented generation is very small. Example, a user asks the recent financial news instead of relying on the potentiality outdated pre-trained data. The lag system puts real-time information from the trusted news database. Second future trend is a multimodal and conversal search, conversational search. Conversational search can be done with the generative AI already. Search system will process text, image, voice, audio, video, moving picture. The third future trend is the semantic search and knowledge gaps graph. The semantic search AI model will understand the meaning of the query, retrieve the information based on the concept. And here I have the KGs, knowledge graph. Long graph supervisor is there. It can create the knowledge graph. This is the kind of map relationship between entities, providing a structure for contextual retrieval. Combining the large language model with the KG will improve the accuracy and reliability. Example, KG knowledge graph can resolve the complex query like finding the director based on an actor in the film. Not finding an actor in the film. If we input, then the film director will appear as a result of the information retrieval. Knowledge graph makes us. This is the schematic view of the semantic search, different aspects of the dye and the textile fabrics. These sentences can be converted to the vector. In the vector space, blue dots represent the query vector. Orange 1, 2, 3 represent the vector of the document in the database. And we can calculate the distance between query and the data document. And then retrieve the data can be provided, outputted from the semantic search result. Starting from the prompt, it's transformed into a vector embedding in the database, and compare both. Similarity can be calculated with cosine theta and returned as a most similar document. This is the semantic search. The fourth future trend is a proactive and a predictive retrieval. The result will be highly personalized using location, history, and preferences. So if I arrive to the Jakarta airport with my smartphone, then smartphone tells my location. In the history, I have the search history. In the preferences, I prefer to meet with someone in the Bengkulu University people. Such a preferences in the search history and the location, the proactive and predictive retrieval tells us the result, most appropriate results. Integration of the real-time data, it's a kind of real-time data. So once I arrive at the Jakarta airport, then the someone in the university people can meet me. Example, AI assistant could proactively summarize relevant financial news if the user loves interested in the financial news. So most relevant financial news will provided by the AI assistant. It's an AI agent. Now, from now on, you would have the log, how it works. Retrieval, augmented generation is an advanced techniques that enhances the capability of the AI system by integrating retrieval mechanisms into generative model. It improves the accuracy and the reliability of the AI-generated content by incorporating external information into generated context. You know, the most of the enterprises create the lag. They have the internal information in internal data in the company, and they have to make a decision, strategic decision in the real-time basis with the internal data as well as the external data. External data, for instance, the social media data can be incorporated through the MCP lab. This is the key issues for the lab. Simple example of the lab with the president of the US. It's a little bit old slide. Joe Biden is a 46th and the current president of the United States. Interoperability and reference to the sources and generate the answer. Joe Biden. Who is the president of the US? This is a query. Retriever has the LLM, large language model, converting semantic means can be retrieved, and the retriever search the Wikipedia. This is just an example. Knowledge can be expanded and updated from the external data and generate the answer. Retrieve the document by using the document, generate the answer. Another example, common problem with the search retrieval systems. First one is user query. Second one, search for the nearest document, as I mentioned before. And third steps, retrieves context. And the fourth one is the response. If the issues don't have any document close enough, this is one of the problem. The most similar, not equal to most relevant document. This is the second one. Third one is bad response. These are common problem with the search and retrieval systems. That's why we use the MCP lab. Here I have the host agent, AI agent, with LLM, the client agent, MCP server, and the knowledge base and database are underneath of the knowledge sources. User makes a query with the natural language. LLM understand the meaning, contextual information, and the relevant information from the MCP servers, structured data, unstructured data, and semi-structured data are included in the knowledge sources, knowledge-based systems. These are internal data. Also, it can retrieve the external data. Here's the schematic view of the generative log architecture. First one is the retrieval. The second one, augmentation, prompt, template, and embedding to the vectors. Third one is augmented input text for LLM, large language model, and generates the answer. And the answer will be provided to the user's task agent. This is a process flow of the log. Core concept of log is a traditional large language model relies solely on their trained knowledge, which is static and may become outdated. Log addresses this limitation by incorporating an information retrieval mechanisms that fetch relevant up-to-date data from the external sources. This means for instance, social media data, MCP, and model context protocol enhancing this capability. That's why I recommend you to use the MCP lab, not merely lab. Enable to retrieve both structured and unstructured data. You must know the structured data. These are examples of the structured data in the Oracle database and the SAP data. These are structured data. It can be used directly, but nowadays we do have the plenty of unstructured data, image data, moving picture, voice data, IoT sensor data, such and such. And we can use both structured and unstructured data. For the unstructured data, we can convert from the unstructured data to semi-structured data. And then data product platform, we can use these two data. User can this is a query and the retrieve data. Query in natural language converted to vector by using large language model and vectorized mechanisms. Data retrieval, generative AI, data fusion can be done, and the query to the data product platform. This is the data server, and generate context and structured data, unstructured data, and through the LLM, the answer is convert from the data to vector data to natural language and respond to the users. Augmentation. Retrieved data is combined with the user query using prompt engineering techniques. This augmented input provides additional context for LLM and generation. The LLM generates a response based on both the user query and the retrieved information. Then the response data comes out from the MCP lab. Internal proprietary data, so very specified and secret data. Tokenizer allow us to convert from the document to tokens, and embedded allow us to convert token to vector. Here I have the vector database, and a similar document will be searched. Then the user query plus context can be translated to natural language with the large language model and generate the response. Now, this is the typical flow of the MCP log. This is the same thing: user query, semantic search, context-based result, and prompt through the large language model, generative language model, provide the answer, and the enterprise search makes the response to the users with the natural language. LAG stands for retrieval, augmented, generation. First one, retrieve. Here's the document in the database. These documents are chunked, divided into plenty of the small pieces. This is called chunks, and embedding model. So chunks are vectorized, vector base in the database. And here I have the query embedded model allow us to convert from the natural language to vector, and the vector database. We can calculate the similarity by using cosine theta, and the most appropriate answer with the context, prompt, template are there and augmented, and the result comes out from this augmentations and generate the answer, and the response will be provided to the users. Index data or indexing document, chunk, and vector database. This is a very important process. And the query vectorized and compare both, retrieve the data, augment the prompt, and prompt the context. And by comparing the query and the augmented prompt data, then make the answer. Through the LLM, the answer will be converted to natural language and response to the users. So that the indexing here is very important. External data text document or database is divided into the small chunks. These chunks are converted into vector embedding using embedding models. The embeddings are stored in a vector database for efficient manner. And the techniques used is that the hybrid search combining semantic and keyword approaches. This is an example for the query, like what is my annual leave balance? The system retrieve leave policy document and personal record will come out from the search. Augmentation. Semantic search. After that, augmentation. Enhance the user query by integrating the retrieved information and the additional context. That's why this process is called augmentation. Expand. Retrieved documents are appended to the original query using prompt engineering techniques. Prompt engineering is a key issue here. This augmented prompt provides richer context to the generated model, improving the relevance and accuracy of responses. And then generation of the response. The augmented prompt is passed to the large language model, generates the response that incorporates both retrieved with knowledge and its pre-trained understanding. And maintenance updating repeatedly so that the MCP log getting more clever and clever. Regular pro updates index the data through automated or batch process. Recompute embeddings for new or modified content to ensure accuracy in retrieval. Here I have the log starting from the data collection, information extraction, chunking, embedding, and index, and search retrievals, and LLM. These 6 elements are major components of the retrieval augmented generation log. There are some challenges and the considerations of the log: data quality, availability, integration complexity, computational cost and resources, privacy and ethical concern, scalability challenges, so that I tried to create my MCP log in my laboratory. From the user makes a query, retrieve in the database, and the response will be created by LLM. In the query user interface, web interface I created by using Streamlit. Streamlit, Python code available from the GitHub or Hugging Face. Final log systems. This one is a prototype. This one here is a final type. React protocol and fast API protocol. As database prototyping, I used SQLite. SQLite is very light, very small, so that the final log system was created by using MySQL, ChromaDB. These are relational database. And the LLM, I created GPT 3.5 Turbo 4.0, ChatGPT 4.0. So we can retrieve the data with a natural language. Sorry about this in Japanese. Here I have the document database, and the LangChain is one of the tools, sophisticated tools of the log systems. LangChain and LangGraph are AI agents allow us to create the log. LLM, OpenAI, this time I used. So retrieve the data in the database, augment, search result, most high-ranked information will be provided, and retrieve the information is integrated through the LLM. The answer is created by generation. That's why lab. In the database, as I mentioned before, MySQL and the Chroma database used for the database management. Here I have the another technology which allows us to make a SQL command by using a natural language, so-called text to SQL. Natural language to SQL, because the specialist for the SQL command is no doubt to use the SQL language, but not for the general person. So that the text to SQL is a software tool which allow us to convert natural language to SQL language. This is the example. What are the top selling products? This is a natural language. And into text to SQL query like this, select product name from product order by sales desk limit 1, such this SQL language comes from the natural language. What are the top selling products? So we don't need to know the what is the SQL language, SQL command. By using natural language, we can retrieve the data in the database, SQL database. Machine learning method, trained model, using large amounts of the natural language SQL, so that the this text to SQL is available from the GitHub and Hugging Face data sources. Technological trend of the MCP log. We can expand the generative AI, not only ChatGPT, but also Gemini, GPT 5.3, and Claude or some other generative AI. And prompt technology, there is the COT, chain of thought, zero shot and few shot learning is available. And multimodal support. That is one of the example of the demonstrations. Prompt framework using Anchor bots. This is the query, and this query converted to SQL by using text to SQL. MySQL selects asterisk from accessories where framework ID in 1, 2 and part name like percent framework percent, such like this. And the response is here. Sorry, Japanese again. Here's the demonstration. Here's the query in Japanese. And if I click this radio button, then the search result comes out from here by using AI agent. Here's a demonstration I put, and some delays. After that, here's the response. Okay, so such this log, MCP log, can be created very easily. Only 4 hours will be enough to create such this prototype. So prompt engineering uses query here, the SQL command over here, and Streamlit, the functionality is limited so that I change the Streamlit to React for the front end and the fast API for the back end. And the MCP lab. MCP stands for Model Context Protocol, and the MCP host as a language model, MCP client control MCP servers. Underneath of this MCP server are there, log database, external information such as the SNS, IoT, etc., through the internet. We can use both internal information and external information together. MCP is a kind of protocol required for the AI agent. AI agent can perform multiple processes in response to user request. MCP support allows for this combination to be freely archived. MCP is a kind of T5 socket. Here I have the users and the answer key provided MCP protocol. We can access to the database, MCP server, calendar, Notion, and Box, external tools through the MCP client, access to the MCP server. And then user asks some task to the MCP client with the natural language. And then the MCP client gets the data from the MCP server. so that this MCP is a type C connector, connected to all kinds of the database. Here I have the another LLM and generative AI, GPT 5.3, another LLM, Gemini, Claude, through the MCP. These MCP are the same, so that the MCP host with the LLM, Claude desktop, I recommend to use IDE, integrated development environment, agent applications, MCP client, protocol which connect MCP server, again, Claude, and long chain I recommend, and the MCP server, SQLite, MCP server. Here's the best famous MCP server provided by the GitHub or Hugging Face. Local data source, SQLite, JSON file, remote service, nation API, transform cloud, Slack API, etc., etc. There are so many remote services. By using remote services, we can collect the external data with the API. Here, the server A, B, C, web API through the remote data server can be accessible. Source A and B combined together, and then create the answer, respond to the users with natural language. MCP server, JSON RPC 2.0. This is the fixed format, so that it's easy to create MCP server downloaded from the GitHub. This is the another development way by using the AWS, Amazon provided cloud computing resources. Intelligent SDK is the tools for the agent configurations, invoke and the response through the MCP servers. External API can get the external information. For instance, the SNSN data and the internal data in the cloud of the AWS. We could get the response and create the answer and provide to the users. AWS provides the MCP servers. GitHub provides downloadable of the MCP server code, software code. Microsoft provides Playwright MCP. This is another MCP server, so that you can choose one of those. Azure provide MCP server. So most of the cloud platformers provide MCP server. That's why I recommend you to use the MCP lab. This is a Windows-based MCP lab, MCP registry for Windows. So not only the Linux OS, but also Windows OS, Mac OS, the MCP lab can be created. The first API MCP is there to the backend. So fast API, MCP, can be created, and the MCP server with the cursor, the cursor, it's an AI editor, so that you can create your own software code with the cursor. Cursor-based MCP are there. So if you enter the cursor environment, you can create the MCP static database and external database. We can access both services when the user asks what are your free appointments next week, such like this. MCP client asks MCP server for available services. Such this retrieval systems can be created with the MCP lab. That's all for now. Final message to you, all of the audience, is that why don't you create the MCP server for your university? So many faculty, many departments can be access the same internal information as well as the external information source you can retrieve. So that is my final message to you, all of you. Any questions from the audience? Is there anyone?
Hello, students. Do you have
Yeah.
any questions? I have one
Yes.
question. I'm a user of Gemini, and then lately I activated this personal intelligence option of Gemini. It seems that it has ability to understand my chat across last few months. So it become indeed more personal to me. I'm thinking about the privacy issues. Google indeed already have a lot of data about me because I'm using Android. But now Gemini seems to be able to connect these various data I have in my Google Drive. What do you say about this in terms of privacy?
Unfortunately, there is no privacy at all. Gemini and ChatGPT, some other generative AI uses the cloud computing resources. That means in the cloud, some attacker can access to your personality. If you use the Gemini and the Google Drive and the ChatGPT and also some other generative AI, these generative AI and Google Drive are existing in the cloud computing facilities. So don't input your personalized information to the generative AI. Did I mention it clear?
Yeah, it's clear, but it's kind of very difficult to avoid nowadays, right? Because sometimes your photos are automatically uploaded into your Google Drive, and this is very difficult because it seems that Google already aware of what pictures I am taking using my phone. So how much can we trust the companies like Google or OpenAI or other companies?
No. There is no trust, no reliable or protection of the privacy. In terms of the privacy protection, there is no such a company, OpenAI, Google, some other, Microsoft, Amazon, they protect the information, but it's on the cloud computing facility. So if someone pick up a portion of the data, then if the data is privacy data, then privacy was destroyed, violated, stolen. So only the trust facility is a local environment, your own server. So if you use the Google Drive or some other generative AI, I recommend you to use the not the privacy data, anonymous data. So first thing you have to do is to convert from the personal data to anonymous data. There is a software tool which allows us to convert the personal data to anonymous data. I recommend you to use software tools for the conversion of the personal data to anonymous data.
Of course, there are some perceived benefits of letting Gemini know your personal data, because sometimes or many times it helps you in your daily jobs. So if we do not provide this type of data, sometimes we have to do it manually. So there is a kind of dependency are building when user of Gemini or ChatGPT or Cloudy are becoming psychologically dependent on this AI. This is bad. I think this is bad, but it is happening to many people. What do you think? How should we get the balance from this? The benefit or the help that we receive or perceive we have from the AI and the price that we have to pay.
Yeah. Yeah, that is a permanent problems for us. Benefit or losses, we are losing the personalized information. For instance, if I talk with you for 10 seconds, then my voice can be characterized. Then the ChatGPT can talk like me, very resemble to my voice. Such a very skillful events are occurred usually nowadays. And deepfake, it's easy to create the deepfake imagery data or moving picture, such violating the privacy, and then it's also beneficial. So a trade-off between both have to be done. But for the university people, we have to care about the personal information, student data that must be anonymous data, not the actual name and personal information, or uploaded to Google Drive or generative AI. First thing you have to do is to anonymous conversion. Then use the beneficial functionality. That's my concept for
Okay.
the. Mhm.
Yeah, I think everyone is trying to do that, but hopefully that most of the people will be able to anonymize the information
Mhm.
and can balance or doing the trade-off between this benefit and I would say danger of AI. One other thing, Professor Arai,
Mhm.
it's about the divide. We have previously have a digital divide, and I think in the future we will have a kind of artificial intelligence divide when many people is having access to AI and becoming or getting a lot of benefits from AI, but
Mhm.
maybe majority of the humanity will simply do not have access to AI because AI is actually expensive. Now the price may be affordable, but I think there will be time that the price will become more expensive. And
Mhm.
when it comes, few people will have access and majority people will have access. It's very similar to internet. If you are living in a city, you have access. But if you are not in the city, you may not have access. So this kind of divide will exist. And what do you think about it? What will be the scenario in the future?
Mm. I'm optimistic against the and concern of the AI divide or digital divide, because the most of the Indonesian people uses the smartphone, right?
Yes.
And they can use the AI by using the smartphone, so that the benefits of the AI can be accepted by the Indonesian people. In Japan, the elderly person hate the smartphone. Such a person cannot receive the benefit of the AI, but it's a small portion of the population. So most of the Japanese people and Indonesian people can use the smartphone through the smartphone. Benefits of the AI can be received. So for us, university people, would be better to provide some of the smartphone applications, web applications, which allow us to receive the AI benefits. For instance, that you may reserve the hotel, you may purchase the Saga game ticket, or some weather informations, or some other services through the AI with the smartphone. So as many as I can, I provide the web applications to the people in the world. So this divide and the AI divide will be disappeared.
Yeah, we simply have to work toward minimizing the divide, right? Yeah. I see Rahul is raising his hand. Do you want to ask something, Rahul?
Yes. Thank you for the opportunity, sir. So my question is, I have two questions. So the first one is for the context. I'm using
Loudly, please. I can hear you.
Do you understand me, sir? Before.
Bicara lebih keras. Kurang keras orang.
Okay, Pak. So I have two questions, sir. Is that clear?
Not clear.
Suaranya, Pak?
Not clear.
Okay, wait.
You may use the chat.
Or you can
Chat
chat.
questions.
Okay.
Yeah.
How about now?
Oh, okay. That's fine.
Okay, sir. So the first question.
Two questions.
I have two questions, sir. Okay. The first one is I'm using a few code assistant like anti-gravity by Google and Cloud Code by Cloud AI. And then on the agents, they provide more than one models, such as on the anti-gravity, they provide Gemini models, Cloud Sonnet, and others model like open source by ChatGPT. And my question is how these models can talk to each other on the one for one response. Like the first time I'm asking on Gemini models, and next after that response I change the model, but this model can also understand purposely my questions. Do you understand, sir?
Not clearly, but you are using the anti-gravity, right?
Yeah, yes, sir.
And Sonnet and ChatGPT and Gemini.
Yes.
Yeah, anti-gravity. How do you think? You
Uh,
know, once we yeah, use the anti-gravity, it's very sophisticated.
yes, sir.
And amazingly, they created a nano banana, you know?
Yeah.
Yeah, it's very surprisingly uh, good good quality of the moving picture can be created and very skillful. So we can imitate the all the things in the world. So it's very skillful. And Sonnet, ChatGPT, and Gemini, yeah, you can use all these, the generative AI and model creation is not uh, topics. I mean, the future trend that we need to more concentrated on the privacy issues and security issues and the ethical issues, not the technical issues.
From that, I want to ask about how can, when we are using anti-gravity, in the beginning, we are chatting with, for example, Gemini, and after 1 hour,
That's a
we change the AI. Yeah, change the AI to cloudy or something else. Seems to be they are able to understand what we done previously when we are using Gemini. And when we are using Cloudy, it can, it understands. How can it possible?
Yeah, that's a typical way to use the anti-gravity. Before that, before using the anti-gravity, we used to use the Gemini and the ChatGPT and the Cloud Sonnet. These are precursor of the anti-gravity and sophisticated manner to use anti-gravity. That is true.
Yeah. So,
Recording in progress.
And a new model can be created. Another things is that hallucination. In order to avoid hallucination, we would be able to consider the notebook LM. You must know the notebook LM.
Yes, from Google, right?
Yes.
Yeah.
Notebook LM uses the internal data only, not the data in the cloud, so that the hallucination will not be occurred. And
Yes.
Introduce the lag. We can create the lag with the underneath of the notebook area. Sometimes lag MCP log provide the wrong answer or other than the internal information, because the MCP log creates the answer from the not only internal source, but also the external source. If the external source contains the wrong answer, then the MCP log outputs the wrong answer. On the other hand, Notebook LM uses the internal data only. That's why there is no hallucination at all.
Okay, this is the last one because it's almost 12 in Indonesia. Okay. I
Yeah.
have one last one.
Mhm.
So it is told that AI will generate more millionaires in the future in 5 years than what number of millionaires previously existing. So I would like to ask you one business idea that you think will have very high potential to make someone become a millionaire.
You hope so?
I don't know, maybe one of the students.
Mhm.
We don't know.
Totally depends on the idea. New idea.
New one.
Mhm. So, yeah, if I have a time, I would like to discuss with the cooperative research work between us.
Yes, yes. We
New
can.
idea comes out in the last 5 years. There are so many millionaires, and you will be a millionaire in the near future.
Yes, everyone would like to be one, I think.
Mm.
Yeah. Okay, it is 12 already here, Professor Arai. I would like to thank you again because we have been having webinar with you 3 times already with this one. And I hope again we will have another opportunity in the future. I would, I don't know if you have any final remarks.
Yeah.
Yeah,
We have communication tools, email message exchange, and discuss about the new collaborative research work between us and the new idea to make millionaires. Such a new idea comes out, I do hope, in the near future. So I email message, keep in touch with you, all of you. More than 160 students are, audience are hearing my voice, and you must know my email address, so I keep in touch. And I do expect the collaborative research work. That's all for now.
And the last one, I would like to also hear some remarks from head of department.
Hello, Prof. Arai.
Yeah.
I want to say thank you very much. You have get seminar this day. I hope it will be our program for the next year. thank you very much, Prof. Arai.
Terima kasih.
Terima kasih. And that will be all. Thank you very much, everyone. See you
Bye
soon
for now.
again. Bye-bye.
Izin
Bye
sebentar,
now.
Sir,
Bye.
Sir Noval and Prof. Kohei Arai.
Oh, Prof. Arai, can we have a take a picture, please?
Yeah, we will have a documentation in
Oh yeah,
several
we need to
minutes.
have a picture.
Oke. Semuanya boleh tolong buka kameranya dan pakai background zoom.
If possible, video camera must be on. If possible, we would like to have a picture or two. Pak Arfan, are you taking the picture?
Maybe I need another help. Maybe from Mr. Natsir.
Mr. Nasir, can you take the picture?
Take the picture. Wait. Prof. Kohei Arai, may you take off the screen record screen.
Can you see me?
The presentation.
Yeah, presentation, because we will have the documentation.
Yeah, it seems that the screen is still full with the PowerPoint. Now it's better. Yeah, Habib, please.
Okay.
Screen 1.
1, 2,
1, 2,
3.
Yeah, we have
Again.
many screen.
1, 2, 3. Okay, another one.
We have so many screen.
Okay, sorry. Okay, 1,
At screen
2.
3, there is not much open camera.
Sorry, another one. Okay, lastly. 1, 2, 3. Okay, enough. Thank you.
Okay, thank you again. Arai
Thank
sensei.
you.
Arigatou gozaimasu.
You're welcome. Bye for now.
Bye. See you again.
Keep in touch.